Today's lesson, section 9.3, we're talking about three-dimensional coordinate geometry. So now we have new things that we add to our 2D world to make it 3D. So we have a new axis called the z-axis. We have two new planes. So with your xy plane, you also have the xz plane and the yz plane. So that just means that it's a plane that, like if you made the other one, so like xz, that means y is 0, then that's the plane or the piece of paper that you could use to represent those two axes together. And then same thing with the yz, is if x is 0, then that would be a sheet of paper that would represent that plane, those two axes put together. And then now you also have a new part of your ordered pair system, which makes it an ordered triple. So looking at my picture here, this is how I draw my axes. Okay, x, y, z. X axis is now not left and right anymore. It is coming at you, or it is going away from you. Okay, so this part would be the positive part. Over here would be the negative part. Y is now like your x, so it's left and right, and z is now like your y, which is up and down. Okay, so that's the new and weird way of graphing 3D stuff. Okay, so example 1 wants us to be able to plot. So I always draw my x and z, or my y and z first, like you would for your x and y that you used to, and then you make one diagonal that kind of goes at a slope of 1 to 1, or 1 over 1. And then make sure you label your axes, because especially since it's new to you, it's going to look different, so you need to make sure that you label stuff so you understand where to go. Okay, so how I graph these, I use my trace. So, and the other one is going to be hard to show using planes, but I can show you that in class. So for these values, I always just go along and kind of create a trace of where I was, so that I can see where, I can get the dimension to it. Because if you just plot it by itself, you kind of don't really get the visual of it being 3D. You just see it being a point on your piece of paper, and it looks like it's in 2D. So if I come out 3 in the positive direction for x, gets me there. And then for your y, go over 1, so it gets me right there. And then for your z, I go up 1, 2, 3, 4. And this is where graph paper is super helpful, because if I didn't have the graph paper, visually I wouldn't be able to connect the points. Okay. So then that would be my point, 3, 1, 4. Okay. Let's do the same thing for your other one. And I'm just kind of making it so I can actually graph it right. And actually, let's readjust that. Oh, there you go. Oops. That's what I wanted. And then there we go. Okay, so for my x, I go back 3. Okay, and so then 1, 2, 3, right there. Notice how on the x ones, I go to the corner of the box. I don't go in the middle of the box, because it actually makes it easier to graph later, because then it lines up with the other values that I have for the other axes, and so it makes it easier for me to represent it for stuff. So y is going to be 5 over, so 1, 2, 3, 4, 5. And then now I'm going to go down 7. So 1, 2, 3, 4, 5, 6, 7. So then that would be my point, -3, 5, -7. Okay. So that's kind of how to graph that, and we'll do more of those in class because it's kind of hard to show it. Here, example 2, we want to be able to graph a plane. So we'll do the same thing. important to get that slope looking right, and then it makes everything else easier. So then for x equals 2, we want to first locate where that is, so here. Okay. Now if x equals 2, that means that your y and your z's, kind of like if you're graphing this on a coordinate, like a regular 2D one. Let's just talk about that. So if x equals 2 on a regular 2D plane, that means y can be whatever it wants to be, just x always has to equal 2, right? So now, here, y and z both get to be whatever they want. So it creates a plane. So it's a flat sheet of paper that's going out in all directions, except it stays in that sheet of paper, okay? And its x is always equal to 2. So, kind of to do this is you kind of make a kind of a box or a rectangle, or in some cases a parallelogram, to kind of help you visualize this. Now x equals 2 is just going to be a square, okay? So I go out a certain direction in both directions. So 1, 2, 3. Let's just go out 3. 1, 2, 3. Okay? And then I do that same thing. Boop, boop. Okay? So then now I've created kind of a shape, which is a square in this case. And then you can kind of shade it so that now you kids could probably do this a lot better than I can, because you're way more artistic than I am. Because it's hard for me to do it, just because visually I can't see the 3D all that well. But some kids can really do a great job with the shading, so that it really makes it look 3D in a sense. But I, on the other hand, cannot as much. So that's my best depiction. And sometimes I try to draw it so that the shading doesn't cover up the part that's still coming out, so it still gives it that 3D effect, but then also covers up everything else behind it. So this little green part there on the left, I didn't cover up, and that's hard because it's like a weird color, so it just doesn't work well for me, but that's the best I can do. We can try to do it in class so you can see a little bit better, but let's try a different one. So if I have, nope, that was a poor line. There we go. Okay, so x, y, z. So now, so if I have y is -3, so it's over here. Okay, now this is where the parallelogram part comes out. So if you're going up 3, let's say, so right there, and down 3. Now, the parallelogram part comes from like your x value because it's slanted. So you want to do the same thing that the x value does. So you want to go in a direction that's parallel to x. So instead of going straight across or down, you would go at a diagonal at the same slope. So it's almost like you're following that line. So then now you kind of make lines so that they match. Oop, went too far for that one. Oh, I didn't go far enough, that's why. There you go. So it looks like that. Okay, so then now I can cover up everything. Oh, I did a bad job there too, because we want to cover up this part. But not that part, because you can still see it. And it's hard because I kind of covered up the blue, or the purple line here. Let's make that so it's better. Okay? The same thing there. Okay, so because that would go behind it, and that's kind of a little bit better picture of what a plane would look like. Okay, so let's do this last one. Here I'm going to have to fudge a little bit more. Let's say that okay, there you go. So z. So then now, so 1, 2, 3, 4. There's 4. And so then now for your y you go out 3, 1, 2, 3. Okay, and then for your x you do the same thing. So 1, 2, 3. 1, 2, 3. Okay, so here for my values. Oh, yep. So now there, that would be my picture for my z-axis. I'm not covering up the part that kind of sticks up straight up, but I am covering up everything else to kind of give you that visual as best as I can on a 2D. Now, none of these are going to be perfect because we're drawing 3D shapes on a 2D piece of paper, so they're really never going to be perfect with what we want them to look like, but that's the best that we can do with these. Okay? So let's move on. So, distance formula in 3 dimensions. Pretty similar to distance formula in 2 dimensions. Okay, we're just adding a z sub 2 minus z sub 1 squared. So if I want to find the distance between 2 points, then the distance between P and Q is just going to be 4 minus 2 squared plus negative 1 minus 9 squared plus negative 5 minus 6 squared. Okay. Remember, the order doesn't matter for any of those, so 2 squared plus, that'd be negative 10 squared plus negative 11 squared. Okay, and then that gives me 400 plus 121, and then that's going to equal 225, which comes out nicely is 15. So the distance between those 2 points is 15 units. Okay. The equation of a sphere is just the kind of like the equation for a circle, except we're adding another dimension. So instead of just the center being HK, now it's HKL, and the radius is still R, but now instead of just x minus h squared plus y minus k squared like in the 2D shape, then you have that additional z minus L squared equals R squared. Okay? So find an equation in a sphere if your radius is 8 and center is negative 3, 4, 2. So then plugging it in, so x minus negative 3 squared plus y minus 4 squared plus z minus 2 squared equals 8 squared. So let's simplify here a little bit. Now for these, they kind of want you to just kind of leave it. You don't have to FOIL it out or anything, unless it makes sense to do so. But just simplify it as far as you can with the signs, and then simplify your radius squared, make it 64. So in this case, that would be our equation that represents a sphere. Okay. Okay. Now example 5. Now they want us to do stuff with our equations. First they want us to be able to show. So here, you're gonna have to be able to use completing the square with your stuff. Okay. So if I have this equation, x squared plus y squared plus z squared minus 18x plus 16z, or y, plus 6z plus 60 equals 0. Now I want to be able to complete the square. So first you want to subtract the 60 to the other side, and then you want to group your other stuff. So x squared minus 18x plus blank plus y squared plus 16y plus blank plus z squared plus 6z plus blank equals negative 60. So now you're going to have multiple things over here. So instead of just having 2 like you would for a circle, now you have a sphere. So then half of 18 is 9, squared is 81. Okay? Half of 16 is 8, squared is 64. And remember, a half of 6 squared is 3, squared is 9. So remember that that's what I'm using is, this is essentially your b. Okay? So b divided by 2 squared is going to help you complete the square. Okay? So then those are the numbers that I'm going to add to the other side. So 81, 64, and 9. So when I complete my square, remember that these, whatever you got when you halved it, so like divided by 2, that was 9. That's the number that you put in for like when you complete the square and simplify it. So, and it always has the same sign. So it's negative 9 in this case. So then y, half of 16 was 8, it was a positive 8, so it's plus 8 squared. And then plus z, half of 6 was 3, so that gives me plus 3. Oh, it looks like I'm missing something right there. There you go. So it's a plus 9 there. Okay? And that equals negative 60 plus 81 plus 64 plus 9, which should give us 94. So now they also want us to state what the center was and the radius. So the center was 9, comma, negative 8, comma, negative 3. And then the radius is going to be, remember that the value over here is r squared. So square root it gives you square root of 94. Okay? And that would be your answer. Okay? Example 6 says describe the trace of the sphere. Okay? Now, what that means is find the equation of the sphere if, now like the trace or the outline. So like if I have a sphere, let's kind of do the best we can. Okay? So let's say we took this sphere and we cut it in half. Okay? Then we're looking at part, like it's like if you take a orange, cut it in half, you're looking at the outside or the circumference of the edge. Okay? So that's what they're kind of talking about with the word trace. So they're kind of saying, take your sphere and of this equation, and I want you to look at a section of it or cross section of it, and figure out what the equation would be for the circle. Is basically what it is. So a sphere's trace is going to be a circle. So it's almost like we're going to take out one of the variables and then see what we're left with. So if I have xy or xz plane, that means that in my xz plane, what variable is missing? Well, this x is there, z is there. Nope, no y. So we don't know what x is, we don't know what z is, but we do know that y is 0. So if y is 0, that means that I'm going to plug in 0 for my equation. And then I'm going to simplify my equation to see what equation's left for the circle. Okay? So then 0 plus 3 is squared. So that gives me 3 squared, which is 9. So x minus 6 plus 9 plus z squared, z minus 3 squared, equals 25. Well, I need to move the 9 over. It gives me 16. So this is my equation for my trace, or my circle, and so now my center is going to be 6, comma 3, or actually, so we're still in 3D, so we still need the 0, 3, okay? And then my radius is now 4 for that part of the circle, okay? Now let's say x is 10. So now they're telling you a specific value for your letter, so then that means we just plug that in, just like we did for the y. So then 10 minus 6 squared plus y let's go back, y plus 3 plus z minus 3 equals 25. Okay, so now 10 minus 6 is 4 squared. That gives me 16. Okay, and now I subtract that over. So it leaves me with y plus 3 squared plus z minus 3 squared equals 9. So this is the description of the trace, okay, or the equation for the trace. Now our center is going to be at 10, comma, negative 3, comma 3, and then our radius is now 3. Okay? And those would be my answers. Okay? Have fun.